today's video, we will learn about the reaction of metals with oxygen, right? So, all the metals down to and including mercury in the activity series combine directly with the oxygen to give their oxide. Similarly, we can represent this thing as metal when combined with oxygen gives metal oxide, right? The reactivity of metals towards oxygen depends upon their relative position in the activity series. First, that is sodium and potassium reacts with oxygen at room temperature only to form their respective oxides. Here you can see sodium when combined to oxygen forms Na2O, and similarly potassium when combined to oxygen form K2, right, at room temperature only. So sodium and potassium here react so vigorously with oxygen that they catch fire in the open. Hence these metals are kept immersed in kerosene, right? Sodium burns in air with characteristic golden yellow flame. Second, we have the magnesium, which occupies a lower position in the activity series, combines with oxygen upon heating and burns with a dazzling white light and forms its oxide. You can see here magnesium when combined to oxygen with some heat forms magnesium oxide, that is whitish in color. Moving ahead, we talk about aluminium. When aluminium combines with oxygen at 2535 degrees Celsius temperature, that is a very high temperature, then it forms only the aluminum oxide, that is Al2O3. Similarly, iron also combines with air, but it do not burns during combination with the air. It forms ferric 2 or ferric 3 oxides, that is Fe3O4 or sometimes Fe2O3 when combined with air in the presence of moisture, that is also known as the rust, right? Here, iron does not burns in air. Now, if we talk about copper, that is even less reactive towards oxygen, it combines with oxygen on prolonged heating to form a black coating of copper 2 oxide, that is also known as CuO, right, in solid. It is only formed when copper is strongly heat in the presence of oxygen. Now, if we talk about silver and gold, they do not react with oxygen even at very high temperatures, right? The reactivity of certain metals such as zinc, aluminium, lead, etc. towards oxygen is not as expected from their position in the reactivity series. It is due to the formation of a inert oxide film on the surface of the ordinary temperature, which prevents their further oxidation. That means these metals, that is aluminium, zinc, lead, they do not easily react with oxygen to form their oxides because they form the first oxide layer that is very inert in nature, that prevents the further reaction. Okay. Now, if we talk about the nature of the metal oxide, so generally the metal oxides are basic in nature, right? For example, first, that is the water soluble oxides of metals. The oxides of sodium and potassium, that is Na2O and K2O, they are water soluble and forms a alkaline solution or forms a strong base or alkali, we can say, when reacted with water. Here you can see when sodium oxide reacts with water, it forms sodium hydroxide, that is NaOH, and it is a very strong base. Similarly case with the potassium, that forms potassium hydroxide. Remember that soluble hydroxides of alkali metals such as NaOH, KOH, CaO, etc. are called the alkalis, right? Second, the oxides of metal which are not soluble in water reacts with acid to form the corresponding salt and water. So here, those oxides like oxides of calcium and magnesium, they are basic in nature, but they are not proved by dissolving them in water. They are proved by reaction with strong acids like HCl and H2SO4. They here forms a salt, that is calcium chloride or magnesium sulfate, with the removal of water molecule here. That shows that it is an example of neutralization reaction where an acid is reacting with a base. Base here is the metal oxides that form salt and water. Now, some metal oxides such as zinc oxide and aluminium oxide are amphoteric in nature, right? That is, these oxides react with both acid as well as base to form the salt and water. For example, when zinc oxide reacts with HCl, it forms salt, that is zinc chloride and H2O. Similarly, when it reacts with a base, that is NaOH, it also forms salt, that is sodium zincate. and water. Same case with aluminium, it also forms salt and water when reacts with the acid, and forms a salt and water when reacts with a base like NaOH, that is sodium aluminate and water. So I hope this topic is now clear to you. Thank you.